Welcome back. Today we're going to cover the rest of section 2.6, talking about all these transformations of functions. What we're going to cover today are the stretches and the compressions. So, a vertical stretch. The x values all stay the same, however it multiplies all the y values with a factor greater than 1. So what you're looking for is a number that is multiplying the bulk of the function, okay? That multiplication is going to be your vertical stretch. So you can see in this case, when it's greater than 1, you can see this red function is stretching it up, okay? Just like that. That is your vertical stretch, stretching it up and down. So picture taking silly putty and stretching it out. A compression. So once again, the x values for vertical compression are going to stay the same. But this time it's reducing all the y values by a factor. So think of this as kind of a fraction. You're dealing with a decimal or a fraction that is condensing it, squishing it together. So you're still looking for a number that's multiplying your function, but this time you're looking for a fraction or a decimal, something that is between 0 and 1. And again, you can see that happening with the green here. You can see that blue function is getting smaller, okay? It's compressing it down. Now, to graph vertical stretches or compressions, to graph them takes a little bit more work, all right? You're still going to start with a parent function. So in this example right here, the parent function, is still going to be y equals x squared. All right, so to graph these, that's still going to be my parent. So that's what I'm going to start with. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. Negative 1 squared is 1. Negative 2 squared is 4. Negative 3 squared is 9. But before we graph that, I actually deal with stretches and compressions within my table. All right? So I actually add in that stretch or compression right away into my table because it's easier to do it in the table than it is to do it in the graph. So all I'm going to do is take each of these values and multiply it by 1/2. So I've essentially created a new column. All right, and those are the points that I'm going to graph. So I have 0, 0. I have negative 1.5 and 1.5. I have negative 2, 2 and 2, 2. I have negative 3, then 4.5 and 3, 4.5. So here, the difference in how I graph these stretches and compressions is I include an extra spot in my table for them because it's easier to do graphically, or it's easier to do in the table than it is graphically to multiply by the 1/2 or multiply by 3. So that's the only difference. And then if there were any translations, now after graphing this is when I would take care of those translations, the shifting it around from there. But I graph the stretch, then move it. All right, but again, for right now, the bulk of it is being able to determine what the equation is or describing what the equation is doing. So I'm going to put it all together. So I want to write an equation that stretches its parent function by a factor of 2, translates it 7 left, and 2 units down. So I'm going to start with the stretching with the factor of 2. All right, so that's stretching with a factor of 2. That's going to give me a 2 out front. And here my parent function is a radical. So that stretch or compression always presents itself as multiplication outside the function. 7 units left. That is a horizontal translation. So it's going to be affecting my x. And again, it's always the opposite of what you'd expect. So something that is going left, you actually use a positive for. Then 2 units down, that is a vertical translation. So that vertical translation, 2 down, at the end of my function, I'm just going to put a -2. And now I have my function written for all of the transformations. Let's take a look at this next one. Write an equation that compresses the parent function by a factor of 1/3, translates to 3 to the right, and 1 up. So again, my first focus is going to be that compression of 1/3. So that compression, again, is going to present itself out front. And then I'm going to set up the rest of how my function should look. We're talking about transforming a cubic function, so that's kind of the structure that I'm building. 3 units right. Again, horizontal translations act the opposite of what you'd expect. So right means I'm going to have a -3 in there. 1 up at the end. Vertical translation works exactly the way that you would expect it to. Just move it 1 up at the end. That is positive. Another important skill to have, again, is being able to do the opposite. So we've been working on constructing the equations, but now let's be able to look at an equation and work backwards to describe what's happening. And I always describe it left to right. So the first thing I notice is that 3. Well, that 3 is a vertical stretch. It's multiplying my function. So vertical stretch of 3. What's the next thing that you notice? Well, I see my x being shifted. When x is shifting, that's a horizontal translation. And again, with horizontal translations, you're always thinking the opposite of what you'd expect. So it's going to be, oh, and I almost didn't do it right. Right 1, because that's the opposite of what you'd want to put. And then this +2 at the end is always a vertical translation. And that does work the way you'd expect it to. It just shifts it up 2. All right. So this note was actually pretty brief and quick, but again, very, very critical to everything else we do graphically throughout Algebra 2. So please, 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 if you have any questions on this, you need to ask me because this is of utmost importance that you understand this shifting. So take a moment, please fill out that summary, whether it be any questions you have for me or just summarizing or reflecting on what you learned, and then come back ready for your practice work.